gradient, which is the Nabla f, which is partial of f respect to x, partial of f respect to y, partial of f respect to z. Nabla is the operator that acts on a scalar function, scalar valued function, but spits out a vector. Then you have divergence. Divergence is the Nabla dot f. What does that mean? That means that it's gradient of partial of f respect to x plus partial of f respect to. I'm sorry, guys. That was the most stupid thing I said. Times f, right? And so that f is this, because I said dot product, that should be a vector valued function. So in this case, it would be, so let's say vector valued function. So it looks like this. It has vector 1, vector 2, vector 3. And then you have this is the dot product of the Nabla times the vector value. Easy. There. Then you have the curl. Curl is the Nabla cross f. Again, this has to be vector valued. And f has to be because of the cross product. What is it? Nabla is that. Hold on. Nabla is this. And this is F1, F2, F3. So these are the basic formulas. Gradient works on a scalar valued function, spits out a vector. Nabla works on the vector valued function, spits out a scalar. Curl works on a vector valued function, spits out a vector. Curl is the one that takes vector valued function, spits out vector. The other two do one-way scalar, one-way vector. So that's the story. Let me do one example of this. Should we do for first one? So let's do this one because this is a vector function, vector valued function. The only thing that is defined on that is divergence and curl. So I can't use gradient on that, right? So now divergence and curl. So divergence of that is going to be the Nabla dot f. That's the, let me write it this way also. Dot x, y, z, 0 minus x squared y. And so that is the partial respect to x of x, y, z, plus partial of 0 is 0, plus partial respect to z of negative x squared y. And that is going to be just yz. So that's the divergence of this vector. Now let's compute the curl of the vector. ijk, partial respect to x, partial respect to y, partial respect to z, x, y, z, 0, negative x squared y. That means that for I get partial respect to y of negative x squared y minus partial respect to z of 0 times I, plus for j, I get negative partial respect to x of negative x squared y minus partial respect to z of x, y, z times j. And then the last one is for k, which I get partial respect to x of 0 minus partial respect to y of x, y, z. And then you solve. I think you guys are done. I'm done. If you have any questions, ask. By the way, you in my lecture, I'm discussing divergence and curl on Monday. For those of you in Professor Liu's lecture, it's already discussed, I think, right? Not all the way? Okay, so I feel better because I'm slowing. As I age, I slow down. I used to be very hyper, by the way, but it comes with age, I think. Okay, people in the Zoom, ask questions if you like. People in the crowd, ask questions if you like. Friends? Yes, if is that the cone and a sphere? Yes, if it was the other way around, it would be from 0 to pi fourth. Cone and sphere, if it was the ice cream cone problem, it would have been 0 to pi fourth for phi. I just saw that. Did I miss any other thing in chat? Sorry, guys. I'm not used to, the last semester I was in person, and so I was much more used to looking at the chat. This semester I'm not. Because somebody's always in chat with me.
There wasn't much going on in the chat anyways.
Okay, so you guys figured it out?
Yep.
Okay, good. What is that icon? I've never seen it before. I probably should stop the recording.